Hello everyone, welcome to this video by DataSense. So I welcome you all to the video 3 of this full course, Exploratory Data Analysis using Python. So far in this course, we have covered two major libraries that are Pandas and NumPy. And in this particular video, we will move our conversation to Matplotlib. Now, in any data analysis, along with the numbers and the tables, one major aspect is charts, right? We all use Power BI and Tableau to generate good visual charts so that it is easy to understand complex patterns which you are not able to visualize through just looking at the data. Just for example, let's say there is a time series, right? So let's say there is a time series, it is varying from January to December, right? If you just look at the table in the numbers, you might not realize okay how the numbers are varying, but if you plot the same thing right here in a chart, you will see, oh, my trend is increasing over the years, over the months, right? Similarly, there are other visualizations which are present in Matplotlib. So again, it is also an open source library which is present in the Python, and we use it extensively when using data analysis, when using machine learning, when using data engineering, like whichever task is required. Matplotlib is the most basic library for visualization. Now, based on this library, there are multiple libraries which, for example, 𝐶born, which is based on this. Now, Matplotlib gives you basic visualizations. Now, upon this, there is another library that is built that is called 𝐶born. We will see both of these library in this particular course. Apart from this, there are many advanced features as well for visualization. For example, when you do computational fluid dynamics, right? When you do aileron study and when you do mechanics study, right? There is more very good level of visualization that these libraries produce, but we don't need to go that complex. We just need to have a basic trend and analysis, let's say cluster analysis, segmentation analysis. Those kind of visualization is required for us, and for this Matplotlib and 𝐶born does a they do a very pretty good job. Okay, so enough of the theory. Let's move to the discussion of the Matplotlib. So let's move here. Now we will just first of all walk through a basic theory that Matplotlib is a comprehensive library in Python for creating static, animated, and interactive visualizations, and it is particularly useful for mainly for creating plots, charts to visualize data. Okay, and as we see, like this is data visualization, customization, compatibility. So mainly used for data analysis. So like without wasting time, let's start our basic visualizations. Okay, so the first part we see here is basic plotting. Okay, so we will discuss what all various type of plots are present. The first thing that is we see is line plot. Okay, so we will plot a simple line plot. So how it is done that, so like first of all you need to import the library. Now again, Matplotlib is inbuilt, so you don't need to download it separately. So you'll do import matplotlib. Okay, now remember, like in NumPy we use NP, and for pandas we use PD. Similarly for Matplotlib we mainly use empty. But generally what we do that inside Matplotlib there are multiple classes present. Okay, so for example here our objective is to plot a line plot. Okay, so for line plotting there is a thing called pyplot. Okay, so this is the Matplotlib. Okay, Matplotlib, it has multiple visualizations presented. The first one which we are going to do is line chart. Okay, so how line chart is produced? It is built using pyplot. So matplotlib.pyplot. So what we will do, from class 1 matplotlib.class2.pyplot. Okay, and what are we going to do? Import this as we see PLT. Again, you can change this name as per your convenience, but I'm just using the industry, like how it is used mostly in industry. Okay, now let us say we have to create a line chart. So what is present in a line chart? If you see in any line chart, there is an x-axis and there is a y-axis. Okay, so you need to have some numbers on the x-axis, some numbers on the y-axis, and based on them, some trend is prepared. So what we will do, we'll create a vector of, let's say vector or list of x variables. So how we can do that? So we'll do x is equal to so x is equal to, let's say, 1, 2, 3, 4, 5. Let's plot 5 numbers. Okay, and now corresponding to this, let's say y element which is independent, which is dependent, that is equal to, now let's say it varies 2, 3, 6, 9, 14. Okay, let's say these are the 5 numbers. So we have an we have a list of x which we want to keep at the x-axis, and we have y which we want to keep at y-axis. Okay, so now what we are going to do, we have to from this class we have to call another class, that is plot. Okay, so from pyplot we will call plot. So the code will look like plt, okay, dot plot. Okay, so this class will calling the method plot through plt. Now what we need to do in the plot, we need to pass what is my x-axis, what is my y-axis. So what is my x-axis? X-axis is this list. Okay, so let this be x, and y-axis is my this list. So I'll say y. Okay, now let us say just do a basic plotting. Okay, if I just do this, I have got a basic plot like this. What does it show? That x is varying like this, y is varying like this, and we have a basic plotting of the chart. Okay, so we got our first basic chart. Now we see that we can give some customization to this chart. For example, it is not mentioned that this is an x-axis, it is not mentioned that this is a y-axis. Okay, so we can simply add labels. So how to add labels to your chart is simply call your class, okay, then use another method, that is x label. Now what x label will do, that you just need to pass the label that you want to for the x-axis. So you'll do x-axis. Okay, it is again optional, not required. We just saw that. Now we need to call the y label. So what we will do here, label. Okay, so we'll call our class once again plt. Now we'll use another label, that is y label. Okay, and what is its name? Y-axis. Okay, now let's run this. Okay, now let's run this. Okay, so you see that we have got x-axis, we have got y-axis. Now let's say I want to change my x-axis says let's say number of days. Okay, and y-axis, let's say it says me spend. Okay, and I just do, so it will tell me spend versus number of days. So whatever chart you want to prepare, you can do that. Now another thing you can add to this is your title to the chart. So you'll call your class, and again you'll call the method title. Okay, so this title will give you what exactly title you want to put here. So let's say you can simply say my first Python chart. Okay, so I do this, and I have got this one. Okay, so that's how you build this. Now you can simply call plt.show as well. Okay, and how it is going to do, so it will simply remove those dots, like it will look a very nice chart. So let's say you don't do plt.show, so how does it look like? Okay, and you just simply put anything. So that's how you generate your basic line chart, basic plotting x and y. Now again, this is a very basic thing. For example, how you can use this, for example, let's say you have two variables in your data sets. Okay, column, there's a variable 1, variable 2. You want to plot, you want to cross check how they are correlated, okay, or how they are trending against each other. So you pass one here and one here, and that's how you will generate the visualization between them. So we will see them this particular thing as we move forward in the course. So this was your first chart. So as we saw, we created our first pie plot, basically first line chart. Just one thing I need to mention, that Python code is executed in different environments. Right now we are using in Jupyter Notebook, but you can execute in simple Python file, or they can be executed at various servers on various website, right? So to there, if you want to generate your chart, right, you need to use this method plt.show. Otherwise, you will not be able to show like print any particular chart. In Jupyter it will work. In Jupyter a simple plot will calling a plot will work, but it will not work when you are using Python outside. So in Jupyter we will skip it. Like I will generally skip it, but I will constantly remind you that we have to use plt.show, right? So this question might arise in your mind that if I'm getting chart through plot, why are you using plt.show? So it is just for this purpose. Okay, now let us add few more things to my chart. Okay, now this is a chart. Okay, I see that there is some line, but still, I mean, I can make this more happening maybe, right? For example, so what I can do is the few things I can add. Let's say if I want to change the color of the line. Okay, so what I can do is here where you're using plt.plot x comma y, here you can pass a hyperparameter. These are called hyperparameters, whichever you use inside this. So you can use color equal to, for example, let's say you want to use green. Okay, so you just specify that, and now if you run this, you will get a green line. Okay, so you can change color as per your need. For example, let's say you want to print a red color, so you can get it. Okay, so you got a red color like this. Now let us say you want to change this particular line style. This, you don't want a straight line like this, you want a dashed line. So what you will do is that there is another hyperparameter that is called line style, and you can just specify what type of pattern you want. So for example, let us say I just want like dotted lines, so I will use this thing. So if you see, I got dotted line. Now instead of this, for example, let us say I want some other line. For example, let's say, let's try this one. Okay, it gave me an error. Okay, so this particular let's read out the error here. So this says that this is not a valid for this. So supported values are these and this. None of comma, multiple comma will be used. So we can use only these four type of chart things in our line types. So for example, let's test out this semicolon. Okay, let's say what it says. Let's use this. Okay, so we use, and it got a very beautiful dotted line like this. So remember which all things can be used. And so let's change it back to a dashed line. Okay, and we got it this one. Okay, now one last thing I would like to add. For example, at various points this chart is changing its direction. Okay, like for example here, these are called like where gradient is changing of chart. So you want to display them, so we use markers for these particular points. So how to display markers? In that, you just use, for example, another hyperparameter, that is marker is equal to markers. You can play around with them, like you can simply use O, or you can simply play some, there are a lot of symbols that you can use. Okay, so you see simple beautiful symbols are created like this. So that is how you can play around with that. You can check, like there are multiple hyperparameters which are present. If you check the Matplotlib library on internet, you'll see there are multiple customizations available, but you don't need to get too much into it, because eventually, see, I'll tell you one thing. You will not be creating dashboards in Python. Okay, for dashboards there is Power BI, there is Tableau. Python will be used for your own analysis that you yourself want to understand. So for your understanding, I think basic plotting, basic chart, basic pie chart, they're more than enough. Basic trend line, they're more than enough, right? So you don't need to remember all this. I'm again saying, don't need to remember all this, but yeah, you just should know that. For example, let's say sometimes you might require to print something like this in Python, you can do that. So that's about basic like customization in the chart. So we just saw like how are we using PyPlot, right? And how we can use various customizations to create it. Remember, in real life, when you'll be working on data sets, like things will not that be easy. But so remember the architecture. What you're doing is that you're taking two variables, X and Y. And as I mentioned again, you will have data sets. Through those data sets, you will have to import columns across which you want to plot these things, and correspondingly you will prepare those charts. So we will see these things once we start our data analysis. We will see more extensively there. In this particular video, I am keeping it to the basics, that how these charts are created. Okay, so that's how it is. Now let's move to the, okay, so just let's look at our for example booklet first. So we covered the basic plotting, how we create a simple line plot, right? So what we do, we take X, Y and we plot them like here. Okay, and this line chart is created. Similarly, we can customize it and we can simply like plot markers like this. We can change the dashed lines depending upon how we want. So this was my first chart. Now I will create my second chart, that is scatter plot. Okay, so remember there can be multiple charts. For example, there can be a pie chart as well. There can be donut chart. So there are a lot of things. I'm not going to cover every chart, but I will cover the major ones. Rest all we will use once we start getting things in our data analysis. Okay, because if I start covering, there can be more than 50 charts. This video will go beyond 5 hours if I start explaining all the charts, so it will become very confusing. So rather, let's keep it to 4 to 5 major things. Just understand how things work, and we will use that knowledge in various use cases as we see. So for example, let us say I want to print a scatter plot. So what is a scatter plot? You know that X and Y are there and things are not in form of line, they are actual points. So what you do, first of all, let's say we have these particular points. So 1, 2, 3, 4, 5, and we have for example, things are not linear. For example, they are very much scattered. So for example, let's say things are 3, 7, and let's say 1, again it becomes 5, so 3, 4, and let it become 9. Okay, let's say things are like this. Now what you want to do, from the PLT method, you don't want plot, because plot we already did it. Now we want scatter. So what you will do, you'll change plot to scatter. Scatter is another method in PLT, in matplotlib.pyplot. Okay, now let us say, let's remove the color and all that for now. We will add them again to check what all things are present. Now let's say this is x-axis. Okay, now this is y-axis, and let's say this is my first scatter plot. Okay, scatter plot. So let's run this. Let's see what comes. Okay, so see, we have got our first scatter plot. So in there, things are, we can see things are distributed at various things, and you can just track them like in whatever format you want. And you can add your customizations as well, as I just mentioned. For example, let's say you want to change the color. You will go here, you'll say color, let's say is equal to, for example, red. You want the red colors. Okay, or you can give RGB color, whatever you want. Now another thing you can do, you can vary the size of this. For example, let's say what you do, you just do simple S is equal to, let's say 50. Okay, so these are the sizes. Let's say you change size to 100. Okay, so what is happening, the size of this like plot, these circles are, these dots are technically increasing. Okay, and the last part that you can do is, for example, let's keep it, you can call a marker. So marker, you can call multiple methods. So one of the thing that I'm using is so you can use this particular sign, and so you see you got markers like this. So it is again a simple thing, just like normal line chart. This is similarly scatter plot. Okay, so remember, there is line, there is scatter, there can be pie chart as well. You can do lot of things. Okay, so now we will move forward. So before we move ahead, I would like to show you one difference between two major charts that we will be using. They are called bars versus histogram. Okay, so I'm not sure if you guys remember this. There's a very thin line between these two. So what happens in bar chart, what we use categorical variables, and we print, let's say we generate their sales. For example, let's say I have to print or display columns of sales from January to April. So what I will do that okay, I'll create a basic line like this. I'll have January, okay, and I will have February, and I will have March, and I will have April. Okay, this will be my x-axis, and on y-axis I will have my data, like for example, let's say this is my one bar, okay, this is my second bar, okay, and this is my third bar, and this is my fourth bar. So if you notice, there is a difference between two bars, right? There's a spacing between these two bars. It is because these all are categorical variables. In bars, the thing on the x-axis is categorical. It is discontinuous, okay? But when we use histogram, we actually show how things are present on a huge scale. For example, let us say you want to check the distribution of sales across each age. So what you do, this is age 0, age 15, age 30, okay, age let's say 45, and age 60. You want to check the sales of a particular product across age groups. So what you do, that you check, okay, 0 to 15, the sale is this. Between 15 to 30, sale is this. Okay, between 30 to 45, sale is this. And again 45 to 60, sale is this. So this is called a histogram. In histogram, the x-axis is not categorical. So for example, it is a continuous variable. Okay, it is a continuous variable. So that's why you don't see any spacing between these two. So this is the major difference. Like lot of times of course you will not be asked this thing in interview, but like somewhere you should know this, that what is the difference between bar and histogram and when to use what. Okay, so when you are having categorical variables, you will be using bars, and when you are using continuous variables, we'll be using histogram. So we will build our approach to print these two. So first of all, let's print our basic bar charts. Okay, so how we print the bar chart? First of all, we need to have our both x-axis. So let's print, let's get our categories. For example, this is a categorical variable, right? So this can be, for example, let's say January, then it becomes February, then it becomes March, then it becomes April. Okay, so let's say this is my data. Now what I want to do, I want to get the values. So let's say the sales in these particular months. So for example, in January, let's say the sale is 200. In February, the sale is 250. In March, it came down to 175, and again it's let's say 120. Okay, so let's say this is my data. Okay, now I want to so I have imported pyplot, right, which is I am generating. So let me keep it here. Now from plt, what I'm going to do, I'm going to get the bar. So I'll do plt, okay, dots. Remember, we used to call scatter plot or line chart, right? And now we are going to do bar chart. So it will be bar, okay, and you will pass the values. For example, this is categories. It can be any name. It need not to be categories only. You just need to pass in that order. Okay, so for example, let's say you do this, and let me remove this. So let's say what we have, plt x label is my categories. Okay, or you can say month, instead of categories you can say months. Okay, so let's change it to months. So my x label is months, and y-axis is my sales. So this is my first bar chart. Okay, so now I'll just print this. As simple as that. You first of all call whatever visualization you want, you pass the variables, then you pass the x-axis label, y-axis label, and then you pass the title. Now if you generate, you will see bar chart, and you see there is a gap between two bars. This is called a vertical bar chart. So I hope this is clear to you guys. I mean, this is a very simple thing, not very like very rocket science. I mean, you just should know that how to print any particular thing. Now let us say what I want to do is, for example, I want to print a horizontal chart, right? So what I will do is that, let's say I don't want to print it vertically, so I will do bar H. Okay, so in bar H, this is my category, this is my sales. Okay, and my first, let's say you can say horizontal chart. So if you do like this, you will get the sale in a horizontal format, right? So you can change it as per your convenience. So this was a basic generating any normal chart and then generating any horizontal bar chart. So pretty simple. Now we will move to histogram. So now we will study about little bit about histograms, right? So in previous video, topic we saw, we created bar plots. So remember what I explained, in bar plots there is a space between, because it is based on non-continuous values. It is based on categories, right? But histogram is based on a series of value. For example, let us say what we do, that you have placed number, let's say you roll a you have a number 1 to 100. Okay, now you have this list placed in a box. Okay, every time you pick a chit, you write down a number. Okay, something like this. Now let's say you do this particular process 1,000 times. Okay, 1,000 times you pick a chit. Now this chit could be from 1 to 100, and every time whatever number comes, you write it down. So for example, let's reduce this thing. Let's say it is one time. So let's say you're doing it 10 times. Okay, on the first time number 1 came, second time number 2 came, third time number 5 came, then number 6 came, then again number 2 came, let's say number 5 came. So 1 2 3 4 5 6. Now let's say number 10 came, now number 8 came, number 4 came, number 3 came. So 1 2 3 4 5 6 7 8 9 10, total 10, right? Now let us say you plot the frequency of occurrence of these items. So what you will do, you will do 1 2 3 4 5. So now we will study about histograms. Now, if you remember, just like few minutes back, I explained what is the difference between a bar chart and a histogram. In a bar chart, you have a categorical variables, let's say A, B, C, and you see their value, frequency, whatever is present in there. And what you do in histogram, you have a continuous variable. For example, let's say you have sales. Okay, so from 0 to 1,000, and for every value, so what you do actually, the buckets, you decide yourself that whether you want to check 100 buckets or you want to check 50 buckets between these two. For example, if there are 100 buckets between 0 to 100, it means you will create a bar of width 1. If there are 50 buckets, you will create a bar of width 2, right? And let's say there are, for example, 10 buckets, so you'll create a bar of width 10, right? So depending upon whatever scenario you want, you'll create bars like this. Okay, so this is how things are done. Now we will try to basically do this in Python. Now remember, so like right now we don't have any data. Of course we will have the data when we start doing the practical aspect of this, like in couple of videos from now. So right now let's generate some random data. Also I will explain you how to generate any random data when you are working in Python, because at times it is required. So to generate any random series of data, you can use NumPy. Okay, so you'll do import NumPy as np. Okay, and what you will do, there is a function, you'll create an object which is equal to np, which is the class, and you'll call random. Okay, random, and you will say rand n. So what this means that so it will be dot, and it means a normal distribution. So I'm not sure if you know what is a normal distribution, what is a binomial distribution, like that comes under statistics. So I'm not covering them, but I'm just getting, just assume that I'm getting 1,000 numbers which are like perfectly distributed across between 0 and 1, something like between -1 and 1. That's what I'm doing right now. Let's say I get 1,000 numbers. Okay, Now let's see them. So what we'll do print data. So when you do print data, it will give you numbers between minus, so between two ends, it will give you numbers, and you just want to check basically how they are distributed. Now you want to check the distribution of these numbers. So now let me check if we can generate some. Yeah, so if you don't use rand n, you can just simply generate using rand as well. This will generate any set of values. Okay, so that's totally up to you. Now let's do some random normal distribution only for now. So now how do we get a histogram? So it's again very simple. So import matplotlib .pyplot as plt. Okay, now what we will do, we will get plt dot histogram. To get the histogram, we need to use hist. Now what we will do, we'll provide this value, this variable, that is data. So I'm providing it a series of numbers. Data. Okay, I've given it a series of numbers. Now how many remember I just spoke about here that you need to decide how many bins you want. Okay, so let's say between 0 to 1000 I want for example 30 bins. So what I will do, there is a keyword called bins equal to 30. It means data will be distributed into 30 buckets. Okay, now you can mention color as well. Let's say I just want to keep it blue. Okay, and once that is done, so you can, there's a also variable called alpha. Alpha means what is the transparency of your bars. So let's say I set it to be 0.6. Okay, for the time being. So let's say I do this. Blue is okay. I need to pass it as a text. I'm sorry. So okay, so this came like this. Now what will I do? I'll just do plt dot show if the to get the, so see, I got a distribution like this. Now I've got numbers from this range to this range, something around minus 3.5 to some 2.7, and the numbers are distributed. So most of the numbers, if you see, are distributed between -1 to 1. This is what called a normal distribution, where your distribution curve follows a curve of like this. Now this is not just any curve. Technically it means that this contains 95% of the data. Your first standard deviation, then your second standard deviation contains 67.2. Like those things are there, but let's not go in there. That is statistics. This course is not for that. So now we generated this thing. Now similarly, you can make changes here. For example, let's say I want to change the bins. So I want to have 100 bins. Okay, so if you see, I will have like information like this. So that totally depends how I want to play. I can change alpha to 0.9, and then I can see it will get very dark, these colors, right? If you make it 0.1, it will become little bit transparent, something like that. So this you can use totally, let's say, up to you. So this was a basic thing. Now you can add your basic stuff as well. For example, let's say you want to add plt, okay, dot x label. Let's say you want to add that. So what you will do, provide these are my random values. You can say my random values. Okay, and you close this. Then what you have, plt dot y label. Okay, so you can say what is y label. It's a frequency. So it's the, like how frequently these numbers are appearing in this particular array that we created just now. After that, we will just give a plt dot title, and the title of the chart we can keep it like a normal distribution histogram. Okay, we can keep it this way. So just do this and you will get the names like this. So just like we are doing so far now. So don't worry about the normal distribution if you don't know. Just know that instead of passing this data which I created, I could have passed my own data, which we will do in once we start our further classes, like once we start working on real data. Right now I'm just telling you which all methods are there. So this is a basic way on how you can create a histogram. So now let's read about subplots. Okay, what are subplots? Let's try to understand them, right? And then we'll create few basic subplots. So remember, for example, let us say you have two data of let's say sales of a company one, okay, company one, and you have a sales of a company two, okay. So what you want to do, you want to analyze their sales from January to December, okay. You want to analyze this in a like now you want to compare them, right? So what you will do, prefer to have like you like to have sales of company one here or and sales of company two here, something like this. Or you will like to have sales of company one here, let's say C1, and you like to have C2 there, so that you can actually check, okay, how is C1 varying, how is C2 varying, right? And you can decide whether you want to create like whether like whatever the insights you want to withdraw. Now how to do that using Python, okay. So it is a very interesting concept of subplots. So what you do, that you imagine that whatever the charts, so technically subplot is generating multiple charts in a same white space. So first of all, your step one is to define your white space where you want to create your charts. For example, let's say you define this particular white space, okay. Now you say that, okay, let's say you want to, now I'll ask you this thing. Let's say I ask you to compare two charts, okay. So what you can either have two, split it like this, you will say I will compare this versus this, right? Or you will say, no, I will do something like this, I will do horizontal compare, this versus this, okay. It's totally up to you. So what you will do, the second part is you define areas, okay. So let's say you do a horizontal split, so then there are two rows, correct, two rows and one column. And if there is a vertical split, then there is one row and two column, okay. So this is how things are done. For example, let's say this is your white space, you want to compare total of four, so for example, four things. So first comparison here, second comparison in this window, so sorry, three. And let's say you draw something like this. So you do C1 versus C2, you do C3 versus C4, you do C3 versus C5 versus C6, all. So you're comparing these two, you're comparing these two, you're comparing these two in a single grid. So first you define the grid, then if you see, you have splitted this whole area into three rows and two columns, okay. And inside each you are generating a chart. So this is what we are going to do. So remember, first you'll define space, then you'll define area chart, like where you want to print your chart. So let's do this by practical example, then you will understand it. So for example, let's directly go to Python. So let's go here. For example, let me first read this. Okay. So suppose you want, so remember, first is create your space where you want to draw this diagram. So for that you use, there is a thing, method called figure. So you'll call plt.figure, figure, okay. And you want to give it a size. So let's say you want to give a horizontal and vertical size. You will say fig size, okay. And then you have equal to, so what this will be, a horizontal and the vertical width you will give. So you let's say it's 10,5 for example, for the time being, okay. So you have created something like this. Now right now you've just defined a, so with this method what we have done, we have just created something with something of 10 by 5, right? So let's say this is 10 and this is 5, something like this we have created, okay. Now what I want to do is I want to divide this area. So for example, let's say I want to compare two data sets, okay. So what I will do, I have to split this into two parts, okay. So let us say I have to split into this. I want to do a comparison of chart 1 versus chart 2. So how I will do that? This is one row, correct, and two columns, okay. And then let's say if I have to address this, so what will be the address of this? It will be one row two columns, and there are two, chart 1, chart 2, right? So this is the first chart. So we will, this the location for this is 1 to 1. And what is the location for this? Row 1, column 2, and second chart. So this is chart 2. Remember, this is not starting from 0 to, because this is just mentioning which particular column it is, like it is first column or second column. So this does not take the regular indexing in Python. So this mentions your total grid space, and this mentions the location of this C1, this mentions the location of C2. So let's say we plot the subplot 1 first. So let's say I have to plot subplot 1. So how will I do? First of all, I'll do plt.subplot. Okay, this is the method that we will call. Now remember, what is the location of my first subplot? It is 1 to 1. So I have taken this area, now I'm splitting it into 1 to 1. Okay, so technically this means 1 row, 2 column, and in those 2 columns, this is the first column. So this is the distribution of this particular thing. Now let's give this a data. Let's say I want to print any random data. So let's say the plt.plot. Okay, so what I will give it, let's say I'll give the x-axis, let's say 1, 2, 3, any random thing, and let's say my y-axis values are 4, or let's say you can say, for example, 4, 5, 6, or you can say 1, 2 square is 4, and 3 square is 9. Let's say any random data I have given, for example, for the time being, which is the square of this. Okay, now this is done. Okay, and so I have to name it, I'll call it plt.title, and this is my subplot 1. Okay, subplot 1. So I have created the subplot 1 this way. So now let me run it. So this is, I have created subplot 1, something like this. Now I want to print the subplot 2, which comes to the right of this. So how I will do that? Subplot 2. So I'll just copy this whole thing, code from here. Now remember, what is the location of subplot 2? It is the second column. So I'll say this is 2. And now let us say generate some. So for this 1, 2, 3 was 149, right? So let's do something. Let's call it a cube. So 1, 8, and 3 cube is 27. Okay, something like this. And this is subplot 2. Okay, now if I do run, see, I have got both the charts parallel, right? We can really compare them. Compare them like this. So this is what subplotting does, that you can plot multiple charts. For example, let us say I just wanted to break this thing into 2 rows and 1 column. So what I will do, this is 2 row and 1 column. Okay, so what will happen? I will split it horizontally. Okay, so, and its location will be 1, and it will be 2, 1, and 2. Okay, so now what, it will split vertically. Okay, so now I can see them vertically. Of course, I can change the axis and all that to compare these 2 data sets in a single way. So this is what is a basic subplotting. So I hope you understand that. First of all, we define a white space here, then we split those white spaces here, and then we define each chart. Now you can generate like multiple charts, for example, 10, 15, 16, however you want. That's how it is done. Now let us say I want to add a little more fancy things to my chart. For example, let's say I'm creating a horizontal chart like this. So for example, I have one chart below and one chart at the top. Instead of having one chart at the top, I want one chart like this and another chart like this, something like this. This is the structure that I want to create. Okay, so like C1, C2 small, and C3 big, because you see in dashboards that you create in Power BI, lot of time you can adjust those things here. Now to create this kind of customization, there is another class present in Matplotlib that is called grid spec. So what it means, that you can actually go further in the grid space and you can modify things. So let's try to create a chart like this from the scratch again. Okay, so let me delete this. So let's again do one thing. What we will do, we need to get the grid spec. So we'll do from import matplotlib dot grid spec grid spec as for example GD. Okay, now what we are going to do is, I just want to ensure if I'm using it the right way. Yes. So now let's create a figure size of 10.5 only. Okay, now we'll create an object of, let's call it GS, and what we are doing is that we are taking the class grid spec. So we'll say it is GD dot, now inside this there is grid and there is spec. Okay, now how are we distributing the columns? So let's say I want to distribute the columns in 2 rows. Okay, 2 rows and 3 columns, for example, because one is bigger. If I split just in 2 columns, these two will be equal. But if I want to have one to be little bigger and second to be little smaller, so I can say let's split this particular part in 2, 3. It means 2 rows and 3 columns. Okay, so I have created a figure size. Now, okay, so this part we have created. Now let's go to create the chart one. So what we will do that, let's say C1. Okay, so what it will look like, plt dot subplot. Okay, now we will, inside the subplot, we will not just directly pass the data. So we will first call GS, that we have created this object. Okay, now inside this we need to pass. Okay, so if you see the first chart that we are creating, it is presented this one. So what is its horizontal location? It is 1, and vertical, if this is 1, 2 and 3. So vertically it is, if you see, horizontal position of this particular chart is 1. Okay, and what is the vertical position? Because I have split the whole data set into 3 columns now, right? So this is 1, this is 2, this is 3. So to get this whole thing, I have 2 columns from 1 to 2, correct? So what GD spec does is it actually divides you into the whole scenario. So what you will do, you will say in the GD spec, I am giving it just like a list. So it is starting from 0, okay, which is the first row. Okay, and then you are passing it from 0 to 2 vertically. So horizontally it is, so remember when we used to create the previous subplotting, there the vector like Python starting from 0, it was not required, but in GS it is required. Okay, so 0 to 2. So what it will generate, 1 and 2. So 0 and 1 means first column and the second column. Okay, let's say I do something like this and I close it. Okay, so I have this particular chart one, that object that I have created. So let me create other one as well, just below this, C2 and C3. So what is C2? Subplot. Now because it is also from the first row, now it will just go at the second, right? Because first 2 columns have been taken. And for the C3, what will happen? I will have the second row. So I will have 1, and you can just say till the end, because we are taking all the columns for the third one. Now if I just generate this, you see I have got a chart like this. Okay, now all I need to do is just need to plot the values to these charts. So for example, I can say C1 dot plot. In C1, what I want to plot, I will need to pass the x-axis. So 1, 2, 3, 4. Okay, what is my y-axis? So let the y-axis be, for example, 1, 2, 3, 4. Okay, so this is my first chart, and now I'll just copy it, C2 and C3. So C2 dot plot, C3 dot plot. So what is C2? And let's say do 1, 4, 6, 9. Okay, and here I'm doing 1, 8. This is 27, and let's call this a 64. Okay, so if you just do this, you see you can compare multiple charts in a single space. So it is just like creating a simple white space. Okay, so the whole logic is creating a whole white space on your own first of all. Okay, first you create a whole white space, then if you just want uniform, then you just use subplot, in those subplot, you don't need to start indexing from 0. You can just mention whether it is row 1, column 2 and position 1 or 2. Okay. Or if you're using grid spec, you need to use like pass values as Python vectors, where your indexing will matter, 0 to 2 or 1 to 3, like whatever you want to take. And from there you can create multiple charts, C1, C2, C3, suppose C4, one whole chart here, then again two chart here, C5, C6. So everything is just like a table. So this is what is called subplotting. I hope you are able to understand this. So now we'll move to the last part of this video. So now we will discuss the last part of this video, few miscellaneous thing. They are called customizations, okay, and annotations. I'll speak about customization, okay, and annotation. So what do they mean? Customization mean that, for example, let us say you have a chart present, okay, and let's say it has a value like 1, 2, 3, 4, okay, and here is a value, let's say 200, 300, okay, 400. Let's say your data is like this, but you want to change this. You don't want a number, you instead want it to play with some character. You want to change it to some number or something else, right? So there you can change, although data is numerical, but you can display it in form of text so that it is more readable, right? So that whenever you're presenting to, and let's say any of your manager or stakeholder, you can be more it's basically to improve the presentation of your chart. And what is annotation? For example, if you want to refer to any particular point on a chart, you have to create an arrow that, okay, hey, this point is this, right? So how you can create an annotation? So we will speak about both of these. So let's first of all go to customization. So how do we set customization for our chart? So what I will do for this is, let me just close this. So let's start with a basic, our basic chart. For example, we have, let's say PLT, okay, PLT dot plot, and let's say we name it X, Y, okay. Now we have to, for example, let's say instead of this, I just do X is equal to 1, 2, 3, 4, 5, 6. Okay, I have named this, and Y is equal to, let's say 2, 4, 6, 8, 10 and 12. Let's say my X and Y is like this. Now presently, if I create a chart like this, I will get something like this. Now what I want to do, I want to change these labels, like this 1, 2, 3, 4, 5, 6. I want to change these labels to maybe call something better. So what I will do here is, below this, or maybe let's say below this, what I'm going to do is, there's an option PLT dot, it is called X ticks. Okay, so what does it shows? That you can customize your ticks. What are ticks? Ticks are basically these endpoints which are play. So here we are doing with the X axis. Okay, so what we are saying that take my value, which is 1, 2, 3, 4, 5 and 6. Okay, and replace these with some labels. So instead of this, I can say A, B, C, D, E and F. Okay, you can name anything. For example, you want to do January, February, March, April, you can name something like that. For example, your data contains month only in numbers, right? But you want to present them as January, February. For example, let's say instead of AB, let's do it Jan, Feb, March, April, June, May and June. So what is happening? Your data format, you're not changing your data, but the way you are presenting your data in chart, that is something you are changing here. Now similarly, for example, let's say you want to change your Y as well. So what you will do, for example, let's first of all run this. Okay, so you see, if we just run this, we see my X was changed from 1 to 3 numbers to instead characters. Okay, my data has not changed, but in chart I'm displaying it in a better format. Now let us say I want to change things at Y axis as well. Now let's say, for example, I don't want to change all. Let's check, does it work out? For example, I have 6 values. I just want to change for first 4. Okay, so for remaining I just don't want to change. Let it be like this. Okay, let's see if it works out, or if we need to pass the whole thing. So what will happen, that your things after that, they are not coming up. So because you just changed value till 4 and rest you didn't say anything, so it will by default not come. So it's so rather you should pass everything that you want to change in your x-axis, and also in x-axis, right? Everything should be of the same formatting, then only it makes sense. Now let's copy it for the y ticks as well. So what will happen, instead of x ticks you will do y ticks. Now my y was 2, 4, 6, 8, 10 and 12. Let's say I want to say that values below 6, they are good, they are bad sale. For example, let's say this is so bad, and I will say bad. Okay, value equal to 6 is good, is average. Okay, and values above 6 are good, and values above 10 are very good. Okay, so let's say you do very, let's say you want to play your chart like this. Now you see how your chart is. You can see till up to what point my sale was below average. Okay, up to what range is it above good, and at what value does my sale reaches very good. So you can create categorization like this. Okay, so this is called customization using the charts. Okay, so I hope this part is clear to you. Now I will move to the annotation part, that what is called annotation. So what we are going to do, let us say, so let's say I have to display this particular line only. So let's forget this. Okay, and I have plt dot plot x comma y. Okay, so I have, let's say, this point. Now I want, let's change this to a curve. For example, 1, let this be 4, then this be 9, then this be 16, then this be 25, then this be 36. So this is an x square curve, right? So this is a polynomial curve. Now what I want to do, I want to create an annotation that I want to mark. For example, let's say I want to mark a certain point here somewhere. So what on chart. So what I will do is that I'll go plt, okay, dot annotate. So this means I want to mark a certain point in the chart. So first of all, what do you want to mention there? Okay, you want to say that benchmark value. Let's say you say benchmark value. Okay, or you can also say important value. You want to highlight something in the chart. Okay, 𝐻𝐼GHLIGHT. Okay, this is it. Now where do you, so okay, you want to highlight this text. Now where do you want to highlight this text in the chart? So for that you need to do comma xy equal to the position coordinate. Where will it lie? For example, it is lying at 3, 15. So xy will be equal to 3, 15. Sorry, 3, 15. Okay, now this is the point where arrow will be there, and from where do you want to show, like what should be the initial point of that arrow? You will say xy text. So this is might be new for you, so just you should see and like keep in mind that how they are done. Even if you forget like how to actually write them, you can refer to ChatGPT or Google anytime. But just remember there is something like this. Okay, so you'll say xy test, and then you will pass the value from where this arrow is coming. So for example, let's say I want to depict an arrow from here to here. So I'll say 5, 30. I want to show an arrow from 5, 30. Okay, this is my that point. Okay, now I want to add few settings to my arrow. I'll say arrow props. Okay, it means arrow properties. Props means arrow properties is equal to, so I'll pass a dictionary here. Okay, so what is dictionary? There is some key, there is some value. So what all key I want to provide? Let's say I want to give a color to that. So face color is equal to, let's call it, we can call it, this is blue already, so we can call it red. Okay. And is there anything I can do? We can give, there's also a value called shrink. We can give shrink. So it is just a setting of the arrow. It is not required. Let me keep it 0.05. It only means that how close arrow is, how what is the breadth of the arrow. Those type of settings are there. This is again optional. This is just like color is again optional. So I mean, you can provide it. Otherwise, if you don't do, it will give some default value. Okay, so let's say you do this, and okay, now if I plot this particular thing, so see, I got this thing. I'm coming from this particular point, I'm pointing to 5,6 and I'm mentioning important highlight at 315. So this text is being displayed at 3,15. So sorry, 3,15 is where is arrow is pointing and text is displaying at 5,30. I'm sorry, I reversed it while saying. So this is my point, XY text, this is my point where my arrow is pointing. Okay, and this is my color red, and shrink, like you can reduce, shrink as whatever you want. So this is called depicting annotation, and you can use these charts anywhere you want. So this is how things are done. I mean, I just remember what is this and what is this. XY means where your header of the arrow should be, and XY text means what text you want to display where. For example, let's say I want to display the text at 3,15 only, 3,15 only. Okay, so see, it will become something like this, because arrow is starting from here and it is finishing here, right? So you need to change that. So what you will do, you will say, okay, let's make it 6,6. So arrow will start pointing from here to here, and you'll mention important point. So that's how you can change your arrow's direction. So this was the part of customization. Now let's check our workbook to just ensure we have covered everything. We have subplots, we have advanced customizations. Okay, now after this we have assignment. Okay, so this is the basic assignment that I have given, so please complete that. It is only based on whatever we have discussed so far, right? You will have to create some plots using the values I taught, and you have to submit on time. So that's the end of this video. So we completed NumPy, we completed pandas, and we have completed Matplotlib. After this, there'll be one more library, that is Seaborn, and then we will start moving towards the data part. So thanks again for watching this video. Do let me know how do you like the overall discussion, overall explanation of the video. If you have any particular feedback, do let me know. And if you like it, please like and subscribe to our channel. So thanks again, guys.